All right, here's our next example. For this example, I really only want to kind of guide you initially on how to set it up, and I'll give you some time to try this, and then I'll jot in some numbers, and hopefully, our answers match at the end. So here's example 3. In 2000, 56% of people 15 years or older lived alone. Again, that just kind of comes out of nowhere. This is clearly going to be your claim. All right, now what is it that they're describing? So what kind of variable are they interested in? Are they interested in a qualitative or a quantitative variable? And if I read it again, I see that they're talking about people that are 15 years or older. So again, this would be your population, people 15 years or older. And then we're looking at whether they live alone or not. And so this is a qualitative variable. Because this is a qualitative variable, you're going to be dealing with proportions. So everything that we did in chapter 8 and chapter 9 with proportions, right? The check, the requirements, all of that will now apply. All right, so let's go ahead and continue. Hopefully that is a good hint. Like, always do that. Always ask yourself, what is the claim? What is the variable? And then, is the variable qualitative or quantitative? So let's continue. A sociologist recently surveyed 500 people. So notice they're already taking a sample. So we don't want to focus too much on that. So this is just their sample. So they're already sampling. All right. So if we ignore that, because that's the sample, we don't really want to use that stuff just now. They wrap up by saying at alpha is 0.01. So that's a 1% level of significance. Do we think the proportion has changed? So that's the keyword right there. All right. So let's set this up. The first thing that you want to do is you want to write out the parameter. Remember, parameter is always a population value. So it's either going to be P, it's going to be mu, or it's going to be sigma. For us, because we are dealing with a qualitative variable, we know it's going to be P. So P is going to be the true population proportion, always, of, and in this case, it would be people 15, and I'm just going to call them plus, who live alone. So every time we see P, we're going to be talking about the true population proportion of people 15 years or older who live alone. All right, let's go ahead and set up our hypothesis, and then I'll leave you to the rest. So from the claim, we know that they're saying in 2000. So that was, over 2 decades ago. So that was quite some time ago. And they're saying that in that time, 56% of people lived alone. So that's 0.56. My alternative, again, the only thing that changes is the symbol in between P and the value. Here we see the word change. So we don't know if it's higher or lower, but they're saying change. So that's a not equal to. All right, I think this is everything. The next step that I have on the steps is to check the conditions. So let's go ahead and check the requirements. SRS, independence, and these both are safe to assume. And then finally, we are at the shape requirement. So the shape requirement for proportions involves P's. So it's this one. Okay, so go ahead and substitute, and also go ahead and sketch. So substitute this, find what the answer is, verify that it is bigger than 10. Then go ahead and use that information to say, oh, okay, the sampling distribution then has a very predictable pattern. All right, go ahead and continue doing the rest of this. Refer to the example that we have done previously to determine what's next. Notice here I actually numbered what's next. On this problem, I did not. And I'm not going to number it from here on out because you want to get used to this setup. All right, so pause the video so that you can continue working on this and then verify your answers once you're done. All right, here is the remainder of the work. So we, again, said we have a two-tailed test not equal to, so therefore I'm going to go ahead and sketch a z distribution because I have a p parameter p, and therefore we got to divide our significance level by 2 because we've got two tails. So just make sure that you're careful with this. Alpha is 0.01 divided by 2 is 0.005. Again, just use a calculator, and then we can use StatCrunch to get the critical value. All right, here are my z statistics. Here's my p-values. And always visualize this. So I didn't do it. Let me visualize it now. The z-stat of 0.45, remember that this middle is z-stat of 0. These points that I marked are 2.58. So 0.45, that's here somewhere. Our sample lands here. Obviously, that's in the fail to reject region. You can also do it by p-value. Note p-value 0.6. That is bigger than 0.001. Okay, so the probability, so p-value is nice because it's a probability. And this basically shows that our sample is not unusual. It's totally expected under the null hypothesis. All right, here's my interpretation. Again, follows the same logic as before. So make sure that you're comfortable with all of these steps here because you have to do this now in your homework, and you're going to do all of these steps for every single problem. All right, let's go ahead and wrap this up. So example 4 actually, so whenever you have a two-tailed test, you can always check your work by making a confidence interval. Really, these are equivalent. So only for a two-tailed test and confidence interval, you will get the same conclusion essentially. And part of it should make sense because confidence interval require two regions like this. All right, so anyway, let's make the confidence interval. I'm not going to do it by hand. We have StatCrunch. So the command is stats proportion stats. And then we just kind of figure it out. So we're going to go to stats. One sample. We have a summary. The number of successes. So let's see, in my sample of 500, I believe. Take a look at it. 500, yeah, and 285 of them did. 285. All right, so for the first part, example 3, you filled this in, right, with the appropriate values. So this one was 0.56. This one was not equal to. And you get this. So what we can do is we can edit, instead of hitting hypothesis, go to confidence interval. Now notice, you got to go ahead and tell me the level, which is not something that was given here. But if alpha is 0.01, then the confidence level is 1 minus alpha. So there's a 99% confidence interval. So again, you're basically saying I need very convincing evidence because the probability of a sample just doing this at random is 1%. So again, this is us asking for a lot of evidence before we reject the null hypothesis. So that corresponds to a 99% confidence interval. Oh, and don't, I think I said this in the previous video. Yeah, don't mess with this. It's always going to be standard. All right, here is our interval. So let's write this interval down and let's see what that means. So I'm going to say we are 99% confident that the true, I'm just going to copy paste, proportion of 15-year-olds who live or older who live alone is between. So again, that we're basically saying at this confidence level, the value of P, which is this guy right here in words, is between 0.513 and 0.627. So that's what we did in the previous chapter. Now, how does this help with hypothesis testing? Notice, if you just simply write out your hypothesis, you can basically tell me right away whether they're correct or not. So the hypothesis was that P was 0.56. The alternative is that P was different from 0.56. So how does your confidence interval help you? Well, always compare it to the claim. So again, we're saying we are very confident that the value of P is between 0.513 and 0.627. More precisely, the claimed proportion is actually in this interval. The claimed value of P, in this case 0.56, is in the interval. So what that means is that it could actually be the true proportion. So the true proportion could be 0.56. And so that's why we're basically saying, yep, our sample seems to indicate, it seems to agree with that statement. It could actually be 0.56. If this interval did not have, so pretend that, for example, H0 was P is 0.65, then this interval does not contain 0.65. So in that case, you would reject that claim. And this is how you can combine a two-tilt test with confidence intervals. We're going to continue to use confidence intervals. So it's really important that if you are struggling on any of this, to make sure that you go back in the previous chapter and you just get a hang of those ideas there. All right, thank you for joining me. You should now have enough to do your homework.